viewers, Eric the Car Guy here, back again with another tool review video for you. And today is an exciting day for Eric the Car Guy because I have two things, actually three things. I have a Longevity 40D plasma cutter. I also have a Longevity Migwelder 140, and I have a cart that holds them both. It's going to be kind of long putting this whole thing together, so I'm going to do my unboxing in sort of a non-traditional way and not go through every detail of that because I'd actually like to get to using the tools. So why don't I get started and unboxing these things and putting everything together, and we'll circle back and take a look at what they're capable of. Okay, well, it was a bit fiddly, mainly because I didn't have any instructions or even a picture to start with, but you can use this part of the video as sort of a template as to how the cart goes together. I'm told by the people at Longevity that one of the first projects many beginning welders like to do is make their own welding cart. So that might be the direction that you might want to take, but if you want one that's ready-made, this one fits together just like you see it here. So it's not that difficult once you figure out the concept of it, but it took me a couple of takes, if you will, to put it together. But now that it's together, let's get that plasma cutter and that welder out of the box and put them on here and see what we got. Now let's get the welder out of the box. I'm gonna set this guy up on top here. And we're back. Well, that was something of an unboxing. I did a little bit of homework on these machines to get a little more information about them. I apologize for not covering the country of origin before. All of these units, including the cart, are made in China. Let's talk about the ForeCut 40D a little bit. The 40D is a plasma cutter. It is a 40 amp plasma cutter. It runs on both 220 and 110 respectively. And the way they do that is with this handy adapter. Normally a machine has a 220 plug on the end of it, and all you do to switch it over to 110 is just plug it into this adapter. Now this does change the behavior of the machine. The machine itself at 40 amps and 220 can cut through material up to 1/2 inch. However, when you back it down to the 110, it only cuts through material up to 1/4 inch. So be aware of that. If you're trying to cut through thick material that you're unable to do so, it's very possible you need to bump up to 120 to do that. So be aware of that. But as far as the information that I found that was out there, there wasn't a whole lot in the manuals. There's a lot more if you go to Longevity's website. They have some videos there. They have a few more things there that can help you familiarize yourself with the machine and its controls and also its hookups. Speaking of hookups, let's talk about the interface a little bit and talk about the actual machine here. One of the things that's nice about this, that's different than other plasma cutters that I've seen out on the market, is this air pressure regulator. You can regulate the pressure coming out, which is really kind of nice. And here's your amp control. It goes from 14 to 40 amps. When you turn the dial, and it's not, these aren't different settings, it's a rheostat. So you've got some variable adjustment. You also have this digital readout, which is nice. As far as hooking up to the front of the machine, here's our torch. I should show you that. Here's our torch on the end. It also comes with some new consumables. And I thought someplace, and I couldn't quite find it, they had a little guard that you can put on the end of this. This helps protect the tip when you're doing your work. So it's a nice little torch, and we've got a project that we're going to use this for so we can run it through its paces a little bit. But here's the hookups on the front. Here's the torch hookup, the yellow one, here on the end, and that just screws in like so. Next, this is the pilot arc. You hook up here, it's just this one little lead. Goes onto the front. This is where it might get confusing for you after you get the pilot arc taken care of. There are two other leads here. This, what is this, 7-pin is not used, so don't worry about this 7-pin. I'm really not sure what it's for. Maybe it's for like a CNC hookup or something. But you do hook up this 2-pin connector, and as you can see, there's like a little slot on the end of it that goes into a slot here, so you can hook it up. And lastly, down on the end, we have the ground, and the ground has sort of a little locking mechanism on the end of it. So when you insert it, it only goes in one way, and then you just give it a little bit of a turn, and it's locked into place. So now all the components on the front of the machine are hooked up. We have our ground, which is a pretty substantial ground. This also has some post flow built into it, which post flow is when you're done using the torch, it will continue to run the compressed air through the end of it after you've finished with the torch to keep the consumables from burning up, so to speak, keep them from overheating, keep them nice and cool. So that's really nice that it does that for you. It's a really nice setup for the DIY. There is one thing though, and it also comes with just a handheld face shield in addition, and a wire brush with a slag hammer on the end of it. So both of these units actually came with that, and I really like saying slag hammer. It sounds like an 80s metal band. Slag hammer. Sorry if there actually was an 80s metal band called Slag Hammer, but I do want to show you one thing here though, as far as the hookup in the back. The last thing that you'll need to hook up in the plasma cutter is going to be compressed air. Now, it's really kind of cool. They got this right. There's an internal moisture separator inside the unit itself, so you don't need to run an external moisture separator. That's really great. So all you have to do to hook this tube up, it comes with 2 clamps, is there is on the back here, you'll see the inlet, and I've just clamped on there. But here's where it kind of fell short, and I had to go out and find some way to do this. I had to go out and find this piece in an air chuck to hook up to the other end to get it to hook up to compressed air. So though you don't have to worry about a moisture separator with this unit, which if moisture gets inside the arc, it's going to burn up your consumables. It's just not good for the torch to have moisture in there. So they put that in these later models, it's built in. But having to track down one of these, and it's not even quite the right size, was kind of a pain, but a small price to pay for what you get. I think it's a very affordable unit for what you've got. It's a really nice DIY plasma cutter. And as I said, we're going to hook this up in a little bit. We'll use it for a little project that I've got, and basically try it out. Now let's talk about the Migweld 140 from Longevity. Also comes with some literature in the package and some additional consumables, the additional tips down in here, because these are things that do wear out. There was also other additional stuff, both for the plasma cutter and for the welder itself. This welder runs on 115 volt AC. It is a 140 amp, that's what the 140 is for. It duty cycles at 20% at 90 amps, and it can weld up to 1/4 inch material. So it's, once again, a really nice starter, my first welder kind of thing. A couple of features that are unique to the Longevity unit here is for the wire speed and the arc volts. These are on rheostats. So normally when you have a welder like this, it'll have different presets. So you just click into different presets and they work or they don't. But if you're really into fine tuning your welds, you can do so merely by just turning a knob, like you're turning a knob on a stereo, something like that. So it's very nice to have that. In addition, this also came with a face shield and also a brush and a slag hammer. Yeah, we like slag hammer. This one also came with some gloves. Now, you can hook this welder up to gas. I have a 75%, 25% argon CO2 mixture that'll run through this that is sufficient. If you wish to weld aluminum, you can do so with this unit with the purchase of the additional spool gun that they have available. This is the switch to go between using the spool gun or using the MIG gun. So it's kind of nice that you can weld both aluminum and other materials with it. But as I said, it's an additional purchase. Now, if you don't want to buy gas and you still want to weld, you can get wire that has a core in the inside of it so that you don't need any gas whatsoever. So it depends on the type of wire that you're using. That type of wire is called flux core wire. My gas bottle with the bottle and the actual gas itself ended up being, I think it was about $190 for everything there, that short bottle. The unit comes with the regulator and everything for this, but I've got this all hooked up and ready, and we'll, you know, when the time comes, we'll get the gas and everything set up for the output of the gas, because I will be using gas as I weld with it. Now let's do our torch hookup and ground hookup. We can open up the unit like this. You will notice there was a loop right here. Don't loosen that screw all the way. Just take the ground through the front and just run it through the loop. I did not do that, and as a result, I lost the fastener on the other side of this. Eventually, I go in and dig it out. But so you've got the lead for the ground. You can just come in. There's a hole right here in the front. Underneath, you can just go straight through that to insert it. Goes through there. Ground is going to be the black. Once again, if that loop is still present, leave it present. And you can bring ground up in, put it on there. Make sure it's got a good connection. Instead of my loop, I've just got a piece of tape here that I'm going to be using to hold it in place so that it does not interfere with the wire during operation. That's what I'm trying to avoid. Just try to keep it flush with the case. Now load the wire. You just you loosen this wing nut here, bring it down. Also going to have to hook the torch up. Here's the end for the torch. Make sure there's no debris or anything around these holes. That's where the gas comes in. And you can come right into the front. You may have to loosen this wing nut here when you install it, or else it won't insert all the way if that's still there. But mine's loose. So you can just push it in and then tighten down on the wing nut until you're in a good place. And here's the control that you hook up in the front. There's really just 2 pins coming down there, but it's slotted in such a way to where it only goes on one way. So I'm just going to continue to turn it until it goes in place, and then just tighten it down. Voila. Now to hook the wire up, this is set up for larger spools if you need to, but I don't have a large spool here, so you can just take this adapter. I'm just going to set mine aside here on the cart. Then I can install this. There's a slot here on this. And now, this part be careful with, because the first time I did this, I made something of a mess. I meant to do that. You have to be careful with these, that you don't turn it into a giant bird's nest, so keep a tight hold on the wire. Got a pair of side cutters here. Nice clean section is what I want. You just lift up on this, put it through here. And this is the tricky part where you've got to feed it into that front section there. Okay, now that you've got it fed through the front section, you just bring up that wing nut, tighten that down. That will help hold it in place. Take the torch lead, and I'm just gonna unscrew this end here. And that's what's nice about this torch, is this screws on, which is kind of helpful. Instead of the type that I've seen that you push on and pull off, it seems that it holds it in a very positive way. Now I'll plug the unit in. I'll turn it on, and I'm just gonna hold the trigger. I got this too tight. I'm just gonna hold the trigger until it comes through. Things don't always go as planned. Now we can weld. Yeah, it may come with some difficulty getting the wire through. That's not just this machine. I've had issues trying to load up MIG machines before, so don't fault the machine for that. It can be a problem. Oh, here's some of that flux core type of wire that you can use instead, so you don't have to use any gas. So that's something you can look for if you don't want to commit to a bottle of gas. We have a handy chart up here for the different thicknesses of material and what settings to use, what size wire is recommended. We'll be working today with some 3/16 material. So I believe, with the exception of adding some gas into the mix, that we're ready to weld. But that is the finer points, the highlights of the Migweld 140 from Longevity, the high points of the ForeCut 40D from Longevity, and the cart the M1. Anyway, I've got a little project. Let's talk about that project, and let's use these products to see if I can accomplish that project. So my project is my workbench. This is my workbench. I actually just went through not too long ago and cleared everything off of it. I've been using it a lot more. I like having this big open space to work, but there's a problem. Check it out. Whenever I go to hit anything on this or do anything on this, it's like working on a trampoline. It's just bounces all over the place. So it needs some kind of support underneath the metal in order to keep it from doing this. And today I hope to accomplish that very thing with the plasma cutter and welder that I have from Longevity. Let me show you what I've got to do this with. I have this piece of 3/16 angle iron, is what it's called. I wish I could tell you what type of steel it is, but it seems like a pretty good test for this welder and plasma cutter. I know I'll be able to cut through this material with the plasma cutter. As I said, that cuts material up to 1/2 inch. This is 3/16. And the welder welds up to 1/4 inch. So this should, for all intents and purposes, be a nice little project. But the idea is I'm going to cut out sections of this and use it to support the table from underneath. First, I guess we've got to get the table cleared off and ready to start doing some measurements to see if we can do this. They say you're not supposed to fry bacon without a shirt on. It's sort of true with welding and cutting and such. Here's a shirt that I have that helps keep all those sparks out of those areas that you don't want sparks in. Protective clothing, not a bad thing. Also, I've got some jeans on. Those can catch on fire, but this is supposed to be somewhat fire retardant. In between this and some gloves, my new gloves that I have here. Okay, now I need to figure out my configuration here. Come on down and see what I got. Fortunately, this piece of angle iron seems to fit right up under there perfectly. I'm very happy to see that, but I'm trying to basically figure out my configuration. I know I'm going to have one going down the center like this. I thought of a couple of other possibilities based on the amount of material that I have here. I thought of putting another brace here and cutting it up into thirds. I think I have just enough for that. I had also thought about possibly taking the other two braces and running them across this way, but I just realized that if I do that, I may have to re-drill my holes for my vise, at least on this side. So I don't know if I want to do that. I think I'm going to stick with my original plan and just put 3 braces right along the center and cut this whole thing up into thirds. And hopefully that will provide the additional reinforcement that I'm looking for, so that I don't have that bouncy trampoline feel when I'm working on my bench anymore. I'm just going to say that's good. This is all under the table, so it's not like I'm precision measuring or anything like that. But this should be a good starting point for the first piece and the first cut for this center support. Here's my setup. I have repurposed my vise, as you can see here, on the ground, even though I don't have it on a table anymore. I'm going to cut it right in that area with the plasma cutter, but the plasma cutter needs a good ground. So I'm just going to clean a little space, like say down here, to where I can clean it so I can have a good space for my ground clamp. So we'll see if this all works out. Okay, now I'm going to hook up the compressed air to the plasma cutter itself. I actually had to redo my fitting a little bit. It was leaking out of there. but I've put a couple of hose clamps on it. Hopefully you have better luck. You might need to find one with a larger diameter. I used a little piece of electrical tape that I wrapped around the inside of it in order to give it a slightly larger diameter, and two hose clamps mounted in an opposing fashion. Now it's actually sending air pressure to the unit. Let's talk a little bit about the settings. Normally for cutting 70 to 80 psi on this. If you're cutting 1/2 inch material, try around 90. Right now I'm just a hair over 80 and I'm fine with that. But if you need to change this, you pull out and you can adjust it down or up. And when you have the setting that you like, which like I said, I'm gonna be up around 80, just push it back in and it will lock it into place. As far as amps, I don't have full 40 amps because I'm not running the 220. So I'm gonna try somewhere around 30-ish in that neighborhood. Remember, we have infinite adjustability here, which is really kind of nice. So now I'll plug the unit in, turn it on, and we'll get to cutting. Now I'll add the ground, my freshly cleaned area. All right, most importantly, we can't forget to turn the unit on. As I said, we've got our air pressure all set up. Should be somewhere around 80-ish or whatever for what I'm cutting. I could cut with less than that. Remember, you want it up around 90 or so for 1/4 inch material. It's nice to have that digital readout so you can dial in the amps. And remember, since I'm only plugged into 110, I should only have like 20 amps, but we'll see how well it does. I'm gonna try to put it like on 30 right there for this cut that I'm doing on this 3/16 material. All right, don't point it towards yourself once it's live like this. And the other thing you wanna make sure that you do is as you're cutting, you wanna hold the torch above the material. You don't want it right on the material when you cut. Another thing is if you're trying to blow through some material, don't hold it perpendicular like this. Hold it at like a 45-degree angle to start. That way the material has a chance to escape. If you do it like this, it'll come straight back up and that'll eat up your consumables a little more. So don't drag the tip along the material, just hold it ever so slightly above. Move in a controlled, steady manner, and you should be okay. So let's give this a shot. The torch will automatically run for a while. You'll hear the air going past it after you're done cutting. Completely normal. This is to help keep the tip cool and prolong the life of your consumables. I had zero difficulty cutting through this material at 30 amps on 110 at about 80 psi, like a hot knife through butter. And you can see the result here. Went straight through. Now I may need to do a little bit of grinding on that just to get it to be evened up. There's just a little bit of slag there that you can see. But as far as its ability to cut through this metal, it kind of surprised me, every little movement that I made. So if I were to do this and want to get a cleaner cut, maybe hold my hand on the material and you can use it almost like drawing with a pencil. Let's see if it fits. It's about perfect. For my purposes. Since this is a really nice length, I'm going to use this as my template for my next cut. Yeah, this second piece is going to be a little bit short, but I think we'll be okay. As long as we have two pieces that go in like that. If I did the diagonal, I'd actually need more material, because that needs to cover a greater distance. What I can do is use this piece as like maybe a centerpiece. Maybe I won't do one going across the middle. Maybe I'll do two going across the sides and connect it in the middle with this is what I might end up doing. Either way, we got some cutting to do. One last cut, in fact. Still getting kind of used to it. I'm not too worried because, like I said, this is underneath. So it's kind of ugly because, like I said, it's so easy. You're not actually touching the material, yet you're cutting it. So it's not like you have a lot of positive feedback when you do something like this. I'm going to do a little bit of grinding to get this a little more flush. Also to expose some bare metal to make it easier to weld. And we'll move on to the next phase of our little project here and do a little bit of welding. Just going to try to knock down some of these rough edges here. I'm just going to use my angle die grinder to do it. Make sure you wear your safety glasses, people. Okay, for my plan B, I'm going to lay everything in here sort of in an H pattern. In order to do that, I'm going to need to grind down a little bit off the centerpiece here. Just a little bit. There's some fasteners that are on the inside of the table that I don't want to interfere with. So I'm just going to, like I said, come in and grind this down a little shorter so that way I can bring both outer sections in a little bit more so that they're not making contact with those. And also this one here is sticking out a bit too far, so I'm going to shorten its length ever so slightly on one end here and just sort of grind it down. So in my hand here I have just a regular grinder and I'm going to do exactly that. All right, here's where we're at. I've got this H pattern sort of set up. It's my hope that this provides the structural integrity that I'm looking for. Now, I've had a couple of wood blocks that were up under the ends of this table, which I've moved up under the center. And I've done that so that my angle iron is flush with the bottom of the table because I want it to be flat. Other than that, it bows so much that the center of the table is actually hanging downward. I'm going to fire the plasma cutter again, real quick. Do a quick cut on this so that I've got a nice even surface, then come back with the grinder, grind it so that it's as flush as it can be. That way I get a nice tight weld when I join the material. As you can see, that was a much more successful cut, a much straighter cut. There'll be a lot less grinding as a result. But that's because I was able to hold myself steady as I did the cut. So that was key to getting that without all the little wobbly lines that I had before. Now I'll come in with the grinder, try to grind it as flat as I can. It looks like I got a pretty good start, maybe a little high on that end down there. But I think for the most part we're good. After just a few cuts, I can't say I've mastered it, but I've certainly gotten a better feel for it. With anything like this, practice is going to be your best friend. So you get yourself a new plasma cutter like this, I say grab yourself some scrap and start cutting to see what you can do. You can see that gap's a little bit better now than it was before. It's not perfect, but I think it's good enough, honestly. Well, I believe I have everything cut to size and relatively straight and flush. So I'm going to lay everything in place, but you can't weld onto rust and you can't weld onto paint. So the idea here is, once I get everything laid up into place, I will draw around where I'm going to place these items. I'll have a pretty good approximation of where to clean because the back of this surface is painted. Since I'm having trouble finding my marker, I'm just going to score it. I'm making taking the metal off anyway. I'm going to grab some safety glasses and grab my grinder, and actually I don't think I'll do the grinder. I think I'll just do with some compressed air in my angle die grinder. Okay, so I'm doing some thinking. I now have all the material ground that I believe I need ground, so I've got some bare metal surfaces that I can weld against, which I'm pretty happy about. I've also placed my ground, and I put a couple of clamps on the end to hold the material into place. The more I think about this though, the more I think I should have the table flipped over when I do all of my welding, because that way the weight of the top of the table will be resting on the metal, and it's my hope that gravity will hold the metal in place, because I don't have clamps large enough to reach this center section, but I could always like maybe put a little bit of weight on top, something like that. I feel better about doing that than trying to put my blocks of wood positioned underneath to where they're putting pressure from the top of the table under here, because as I'm doing that, I'm sort of building in a warp into the table. So I think what I'll do is I'll tack things into place here now while it's flipped over, then I'll flip the table over, and then I'll do my welding. Now, I'm not gonna do a continuous bead across every single piece of metal here. I don't think that's necessary. I'm gonna go in about 2-inch sections, and I think that should be sufficient. I'll just put a little weld in and jump to the other side and perhaps stagger those welds. That way it's fastened to the material just fine, but at the same time it's not warping material, because that's something you have to watch when you weld. Is as you weld, it's going to heat the material up, and as it heats up, it's going to expand and contract at different rates, and that builds a warp into the metal. And I want my surface, even though this is a work table, I want it to be as flat as possible. In fact, in some ways I could almost use this as a welding table, because it does have this bare metal on top of it. So that's a possibility, I suppose, for the future. Not really going to concern myself with that for now. I just want to basically get these braces welded in. So I think that the plan's going to be a couple of tack welds, hold everything in place, flip the table back over, complete my welding from underneath is what I believe I'm going to do. I almost like this. Okay, plans are made to be flexible. I like this position. Seems like a good position to weld in. And come in here for a minute. What I can do to deal with this gap is I can push in like this and tack it into place. And that will give me a good position. And I can just run this weld in here and the rest of the welds, because that brings it all together. So I'm just going to hold it in like this, tack it in the center here, and continue to weld the rest. And I might even just, like I say, leave it like this rather than laying underneath it, trying to hold it together. Beautiful. I will be the first to admit that I am not the world's greatest welder, but this is good practice, especially since it's under the table where nobody can see. Guess I shouldn't have put this on the internet, huh? The idea was to demonstrate that one, as a somewhat novice welder like myself, could get these tools from longevity and complete a project like this, and I feel I've completed it successfully. Now that we actually have this welded in, why don't I flip the table up, we'll check the bounciness and see if I succeeded in my task of making it less wobbly. It's a lot heavier. Seems fairly level. It's not going anywhere. That is awesome. I am very, very pleased with this. It's kind of neat, we got these little leeches here now. That's what I meant by the metal heating up underneath. Well, the Migweld 140, the ForeCut 40D, the M1 cart from Longevity Welding. I think they're good value for money. Are there more expensive welders and plasma cutters out there? Yes, there are. Are they worth that money? I think if you're just starting out and you're a DIY, I would say no. I would say that something like this might be more appropriate rather than spending that kind of money as far as what you get. I think you get something comparable with these machines, and I think they function well. Just a couple of issues with the ForeCut. I was a little disappointed that I had to go out and get a special fitting for the air compressor. However, with the built-in moisture separator inside the unit itself, that was kind of a nice thing. So sort of a trade-off there, but I was able to work that out with very little difficulty. You can use the Migweld without gas, should you so desire. You just need to get the flux core wire in order to do that with. We didn't try that or demonstrate that today. Having the rheostats with the infinitely adjustable wire speed and amperage was kind of nice. And having the dual voltage on the plasma cutter was also nice. Was able to cut through that 3/16 material no problem. If you were gonna cut 1/4 inch material, you should bump it up to the 220. And it took a little bit getting used to trying to hold steady with that torch because it does cut so easily. It's very easy to pick up those slight movements that you have with your hand. Also, the adjustable regulator on the plasma cutter was also something I found helpful. There are other things that you need to get, but they do give you quite a few consumables with the tools. I also like on the MIG welder how the tip or this part of the end screws onto here. There were occasions where I did have some problems with the wire feed, but that might have been I had the hose kinked up or something like that, and all it really took was going in there with my pair of side cutters, pulling it out, getting it set up the way I needed to get set up, and I was right back to work. So it wasn't something that really jammed me up. I did have a little difficulty getting the wire fed through the tool initially, but honestly, I haven't played with a MIG welder yet that didn't have some issue like that. But once it was through, as I said, it worked fine. I'll put links in the description to everything so that you'll be able to find any of the tools that you saw or were used here today, particularly the longevity tools. They'll be right there at the top, including the prices. Outside of that, I can't really think of too much else to tell you. I hope you enjoyed this review. I hope there was some educational things in there. Please don't beat me up too badly on my welds. As I said, I'm still starting out. I'm still practicing. It's not something I do a lot of, but I think I'm going to be doing a lot more of now that I have these tools. Hey, if you have automotive questions, I would ask that you head over to EricTheCarGuy.com, where there's a welcome video to tell you about all the amazing features we have there to help you with those automotive issues, should you have them. I do tool reviews every other Wednesday, so stop back if you would like to see another one of those. And you can connect with me socially on Google+, Facebook, and Twitter. Links in the description. And I close each of my videos with be safe, have fun, and stay dirty. I will see you next time.